When we are graphing absolute value functions, we need to use the fact that the line of symmetry is x equal to h, where h is found in the function rule, and the vertex is h comma k, where h and k are found in the function rule. So the first thing we're going to do when we're graphing a absolute value function, such as f of x equals 3 times the absolute value of x plus 4 minus 2, is graph the line of symmetry. So in this case, the line of symmetry, x equal to h, is going to be x equal to negative 4. So the line of symmetry is found from the opposite of what's inside the absolute value bars, and it may help you to think of x plus 4 as x minus negative 4. So the line of symmetry is drawn at x equals negative 4. X equals negative 4. And we're going to go ahead and draw that line of symmetry. A vertical line with arrows. All right, next we are going to plot the vertex h comma k. So the x coordinate of the vertex is the same as that x value found in the line of symmetry. So the x coordinate is negative 4, and then the y coordinate is just k, so negative 2. So we're going to plot the vertex, the turning point of the graph, at negative 4, negative 2. That is the vertex. Next, we're going to graph the right branch using the slope a. So the slope here is 3. So I'm going to start at the vertex and I'm going to go up 1, 2, 3 over 1. Rise of 3, 1, 2, 3, run of 1. Rise of 1, 2, 3, run of 1. And that gives me the right branch of my absolute value graph. There are two ways to graph the left branch. I can either just use the opposite of this slope, negative 3, to graph the left branch. So instead of going up 3, right 1, I can go up 3, left 1, up 3, left 1. Or I can use the line of symmetry to just reflect the right branch to create the left branch. So for example, this point right here is 1 to the right of the line of symmetry. So the left branch is going to have a point 1 to the left of the line of symmetry. This point is 1, 2 to the right of the line of symmetry, so I can go 1, 2 to the left of the line of symmetry, and so on. 3 to the right, 3 to the left. So I could have just gone up 3, back 1, up 3, back 1, or back 1, up 3, or I can reflect my right branch over the line of symmetry. Now to finish my graph, I need to use a straight edge, and I need arrows. I meant for that to be a different color. Let's see. There we go. So straight edge, and straight edge and arrows. And there is my graph of 3 times the absolute value of x plus 4 minus 2. Let's go ahead and check our graph with our understanding of our transformation rules. The 3 makes the graph steeper than the parent function. Yes. The plus 4 moves it to the left 4. Yes. And the minus 2 moves the graph down 2. So we're pretty confident in our graph. Let's look at this next one. First, the line of symmetry. The line of symmetry is going to be x equals 3. The opposite of that number inside the absolute value bars, or we know that h is being subtracted, so 3 will be h. Go ahead and draw my line of symmetry, the vertical line x equals 3. Yeah, pretty good. Next, I'm going to plot my vertex. My vertex h comma k is going to be 3, 1 in this case. So again, the x coordinate is the same as that coordinate in the line of symmetry, or that value. Here's my vertex, 3, 1. Finally, next I'm going to graph the right branch using my coefficient as my slope of my right branch. So the slope of my right branch will be negative 1/2. Down 1 over 2. Down 1 over 2. Now I can only use my line of symmetry to reflect 2 points. So that gives me this point, 2 to the right, now 2 to the left, 4 to the right, now 4 to the left. And to graph additional points, I will need to use a slope of positive 1/2 now. Down 1, back 2. Really, you can just continue the pattern. Down 1, back 2. So there is my left branch. And I just need to complete my graph. Let's see, using a straight edge and arrows. Straight edge and arrows. Oop. Straight edge and arrows. Let's go ahead and check our graph by applying our understanding of transformation rules. The negative is going to make the V face down, or we can think of that as reflecting the graph over the x-axis. The 1/2 makes the graph flatter, and this is definitely flatter. The -2 moves the graph, or the -3 moves the graph 3 to the right, and the +1 moves it 1 up. So again, we are confident in our graph of our absolute value function f of x equals -1/2 x minus 3 plus 1.